Okay, today we're going to look at the graph of a few different functions. We're going to look at first the identity function, so that's just y equals x. We're going to look at how to graph a horizontal line. It's going to be y equals and then any number. We're going to look at a vertical line, and that's x equals and any number. We're going to see how to graph an absolute value function. We're going to see how to graph a square function, like y equals x squared. Then we're going to do a cubic function, y equals x to the third. We're going to look at how to graph a square root function, and we're going to see that that's different than a real square root. A real square root allows positive values, and it also allows negative values. But the square root function only has 0 or it has positive values. There's no negative values allowed for a square root function. And lastly, we're going to learn how to graph a cube root function. Okay, we're going to take what we know about plotting points, and we're going to figure out what the graph looks like for each of these equations. For the first one, we're going to do y equals x. What we're going to do is we're going to plug in these x values into the function. So we'll replace the x with -2, and then we'll simplify. This one doesn't really require much simplifying. And that's what your y value will be. And we'll do that for each number. So when x is -1, we can plug a -1 for the x, and then simplify, and again we're just going to get -1 back. Also, you might notice that it says y equals x. So y is the same as x. So whatever you get for x, you're going to get the same thing for y. So when x is 0, y is 0. When x is 1, y is 1. Now what we're going to do is we're going to go ahead and plot all these points on the graph. Now looking at the graph, you can kind of see what the picture is going to look like. I only plotted 5 points. But this equation, y equals x, is actually the equation of a line. So if we connect all those points, we can see what the graph would look like. So the graph for y equals x looks just like this. Okay, now we're going to look at a constant function. Our example is going to be y equals 3. This is just a line. Now when I'm plugging in values for the x, you'll notice there is no x in the equation. So this one's kind of weird. But this one tells you that y is 3. No matter what the x is, your y is always going to be 3. So this is kind of an easy one. We can just plot all these points. If you look at the graph paper, you can see those 5 points are plotted. And then we just draw a line through those points. And this is the graph of the equation y equals 3. You'll notice it's a horizontal line. It goes left to right. Okay, now we're going to look at an example of a vertical line. Our example is going to be x equals 2. This is the first one where we're not plugging in x values into our function to get the y value. You can see that x has to equal 2. No matter what the y is, the x has to be 2. So we can actually just choose anything we want for y. However, the x must equal 2. Now if you look at the graph, you can see those 5 points are plotted. Again, it's just a vertical line, so we're going to connect those points. There we go. That's an example of our vertical line. That means up and down. And it's the line x equals 2. Okay, now we're going to do y equals absolute value of x. What the absolute value is going to do to an x value is it's going to make a negative number into a positive. So something like this, we're going to get +2. Something like this, we're going to get +1. Everything else is going to stay the same. The absolute value does not affect 0, and it does not affect any positive numbers. Okay, so let's change these to positive. Okay, and those are the points we're going to plot. Now if you look at the left side of the graph, you'll notice that the line on the bottom is going to reflect on the x-axis. And now we're done. This is what the graph of the absolute value of x looks like. Okay, now we're going to look at the function y equals x squared. First thing we're going to do is we're going to plug in -2. So -2 squared means -2 times -2. Your answer is 4, so that's going to be a point, -2, 4. Let's do one more example. Let's plug in a 1. When we plug in x equals 1, we get y equals 1, so that's another point. You can look at the graph, we have all 5 of these points plotted. And if I connect all these points, I can come up with this graph. This is the graph for y equals x squared. Okay, now we're going to look at y is equal to x to the third. This is also called the cube function. Let's plug in a couple x values and let's see how we're getting these points. When I plug in x equals -2, I get y equals -2 to the third. So that's -2 times -2 times -2. When I multiply those three numbers, I get 8. But there's 3 negatives, so 2 of the negatives are going to cancel, and 1 of the negatives is going to be left over. So that's how I'm getting -8. Let's do one more example. Let's plug in a 1. So that'd be 1 times 1 times 1, and then I just get 1. So that means when x is 1, the y is also 1. Now if you look at the graph paper, I plotted all 5 of those points, and if I connect the dots, we can see that the graph of y equals x to the third looks something like this. Okay, now we're going to look at the square root function. So y equals square root of x. Okay, first thing I want to do is I want to try to explain why I chose these values for the x values. This square root is not a real square root, it's just a square root function. If it was a real square root, then when I plug in a 4, you would get y is equal to the square root of 4, and that would have two answers. -2 times -2 would give you the 4, but also +2 times +2 would also give you the 4. So if this was a real square root, you'd have two answers. You would have -2 as one of your answers, because -2 times -2 gives you 4. But you would also have +2 as your answer, because +2 times +2 also gives you 4. So because this is a function, it's a square root function, we're only going to accept the positive answer. So just +2. So when I plug in x equals 4, I just get +2. Let's look at one more example. If I plug in x equals 16, I get y equals the square root of 16. 16 is kind of like 4 times 4. So another way of solving these is if you see the same number twice inside the square root, then that can be your answer. Remember, we're only accepting positive answers. So y equals 4 would be the only answer to this. If it was a real square root, then y equals -4 would also be an answer. But this is just a square root function. Now we plot all these points on the graph, and then we're going to draw a line through all those points. After connecting the points, you can see what the graph looks like. Again, if we were doing the real square root, you would see those points at the bottom that I just plotted on the graph paper. And then I'm going to go ahead and connect all the dots. And this would be the picture if it was a real square root. But again, we're not doing real square root, we're doing a square root function, so we don't want those bottom points. So for the square root function, you're not going to have any of the points on the bottom or any graph on the bottom. So the graph of y equals the square root of x looks just like this. Okay, now we're going to look at the cube root function. You also might see this as written as x to the power of 1/3. Okay, this function is similar to the square root. Let's do x equals -8. For the square root, we were looking for a number that we multiplied twice to get this number, but it's now a cube root, so we're looking for a number that we multiply 3 times by itself, and it gives you -8. Again, I'm choosing x values that I know work out nicely. I know -8 works out nicely. Again, for the third root or cubic root, you'll see a 3 here, and that means we're looking for a number that you multiply 3 times, and it gives you -8. So the answer for this one is -2, because when you multiply -2 times -2 times -2, it gives you -8. So -2 is going to be the answer. When x is -8, your y is -2. Let's do one more of these. Let's do when x is 1. We're looking for a number that you multiply by itself 3 times, and it gives you a 1. Okay, this is kind of an easy one. 1 times 1 times 1 gives you 1. So the third root of 1 is just 1, and that's how we're getting this point. If you look at the graph, you can see all the points are plotted. And now I'm going to connect these dots. And now we're done. That's the graph of the third root of x.